Ladies and gentlemen, hello and welcome to Hot Technologies of 2016. Today's title is Harnessing the Firehose, Getting Business Value from Streaming Analytics. This is Rebecca Joswick. I am the second in command for webcast hosts whenever our dear Eric Kavanaugh cannot be here, so it's nice to see some of you out there today. This episode is a little different from our others, and we kind of talk about, what is hot. And of course, this year is hot. The last several years have been hot. There's always new stuff coming up. And today we're talking about streaming analytics. Now, streaming analytics is kind of new itself. Of course, streaming, sensor data, RFID data, that's not necessarily new. But in the context of data architectures, we've been so focused on data at rest for decades. Databases, file systems, data repositories, all for the purpose mostly of batch processing. But now, with a shift to create value from streaming data, data in motion, some call it living streams, they really require a stream-based architecture, not the data at rest architectures that we've been used to. And it needs to be capable of handling fast ingestion, real-time or near real-time processing. It has to be able to cater not just for the Internet of Things, but the Internet of everything. And of course, ideally, it'd be nice to have the two architectures living side by side, one hand washing the other, so to speak. And while the days-old data, weeks-old data, years-old data still, of course, has value, historical analytics, trend analysis, it's the live data that's driving the live intelligence these days, and that's why streaming analytics has become so important. And talking more about that today, we have our data scientist, Dez Blanchfield, calling in from Australia. It's early in the morning for him right now. And we have our chief analyst, Dr. Bloor, and we're joined by Anand Venugopal, product head for Stream Analytics at Impetus Technologies. They're really focused on the streaming analytics aspect of this space. And with that, I'm going to go ahead and pass it to Dez.
Thank you. I need to grab control of the screen here and pop forward.
There you go.
Have you got my spot there somewhere? Oh, I think we've dropped off my slides, have we?
Oh.
So while we're just grabbing the slides up that I can talk to, let me just quickly, let me just cover the core topic. Let me just see if I'm in here now.
Good.
So I'm gonna keep it fairly high level, and I'll keep it to roughly 10 minutes. This is a very big topic, and I've participated in events where we spent 2 to 3 days diving into the detail of what stream processing is in the current frameworks that we're developing and what doing analytics in those high volume streams actually means. So I'm going to just clarify what we mean by streaming analytics and then delve into kind of where the business value can be derived, because that's really what business is looking for now. They're looking to have folk explain to them very quickly and succinctly, where can I derive value by applying some form of analytics to our stream data. So what is streaming analytics? Streaming analytics gives organizations a way to extract value from high volume and high velocity data that they have coming through the business in various forms in motion. So the significant difference here is that we've had a long history of developing analytics and lenses and views of data. We've been able to do processing at rest for decades since the mainframe was invented. The massive paradigm shift we've seen in the last 3 to 5 years at what we call web scale is tapping into the streams of data coming into us in real time or near real time, and not just processing them and looking for event correlation and event triggers, but performing really detailed, in-depth analytics on those streams. And it's a significant shift to what we've been doing before, which is collecting data, putting into some sort of repository, traditionally big databases, now large big data frameworks such as the Hadoop platform, and performing batch mode processing on that and getting some sort of insight. And we've gotten very good at doing that very quickly and throwing lots of heavy iron at this stuff, but we're still really capturing data, storing it, and then looking at it and processing it and gaining some sort of insight through analytics on it. the shift to performing those analytics as the data streaming in has been a very new and exciting growth area for the types of things that are happening around big data. And it requires a completely different approach to just capture, store, and process and perform analytics on. So one of the key drivers for the shift in focus to performing analytics in the stream is that you can gain significant business value from getting those insights faster and more readily as the data is coming to you, as information is being made available to the business. The idea of doing end-of-day processing now is no longer relevant in certain industries. We want to be able to do that analytics on the fly so that by the end of the day, we already know what's happened as it's happened, rather than getting to the end of the day and doing a 24-hour batch job and getting those insights. So streaming analytics is about tapping right into that stream or streams of data, usually multiple streams of very high volumes of data and data coming at us in motion very, very quickly, and gaining insight through analytics on those streams as they come to us, as opposed to allowing them to become data at rest and then performing analytics on them. So as I mentioned, we've had decades and decades of performing what I call batch analytics. And I've put a really cool picture here. This is a picture of a gentleman standing in front of a mocked-up computer that was created by Rand Corporation a lifetime ago. And this is what they viewed a computer in a house to look like. What's interesting is that even then they had this concept of all these little dials, and these dials represented information coming in from the house and being processed in real time and telling you what's going on. And there's a simple example of sort of barometric pressure and temperature that we can see where we're seeing what's happening in real time. But I imagine that even way back then when Rand Corporation put that little mock-up together, they actually were thinking already about processing data and performing analytics on it as it's coming in stream format. I'm not quite sure why they put a steering wheel on the computer, but that's pretty cool. So we've had this, since the invention of the mainframe, we've had this view of capturing data and performing batch analytics on it. And as I said, the big shift now is, and we've seen this from the likes of the web scale players who we all know, they're all household brands of Twitter and Facebook and LinkedIn. That interactive behavior that we have with those social platforms requires not just capture, store, and then process in batch mode, but to actually capture and derive analytics on the fly from streams of data coming through. When I tweet something, not only do they need to capture it and store it and do something with it later, but they also need to be able to put it immediately back on my stream and share it with other people that follow me. And that isn't a batch processing model. So why would we go down this route? Why would organizations invest time and effort and money in even considering the challenge of endeavoring down the path of stream analytics? Well, organizations have this massive desire to get a performance gain over their competitors in the industries that they're in. And that performance gain can be rapidly implemented through simple stream analytics. And it can start out as simple as just tracking real-time data that we're already familiar with. And I've got a little screenshot there of Google Analytics. This is probably one of the first times that people really got their hands on consumer-grade stream analytics. So as people were visiting your website and we're getting these hit counts, with a tiny piece of JavaScript on the bottom of your web page, and the HTML embedded in your website, these little calls were being made in real time back to Google, and they were performing analytics on those streams of data coming from every page on your website and every object in your website in real time. And they fed it back to you in this really cute little web page in a dashboard of real-time graphs, these cute little histograms and line graphs showing you X number of people that hit your page historically, but here's how many there right now. And as you can see on that screenshot, it says 25 right now. That's 25 people right now at that time I took the screenshot were on that page. And it was the first real chance we'd had to play with a consumer-grade analytics tool. And I think a lot of people really got it. They just understood the power of knowing what was going on then and how they could respond to it. When we think of the scale of avionics, aircraft flying around, there's something like 18,700 domestic flights a day in the USA alone. I read a paper some time ago, it was about 6 or 7 years ago, that the amount of data that was being produced by those aircraft was about 200 or 300 megabytes in the old engineering model. In today's designs of aircraft, these aircraft are producing about 500 gigs of data, about half a terabyte of data per flight. So when we do the math very quickly off the top of our head, that 18,700 domestic flights every 24 hours in the US airspace alone, if all the modern aircraft are producing around about half a terabyte, that's 43 to 44 petabytes of data coming through. And it's happening while the planes are in the air, it's happening when they land and they do data dumps. It's when they go into the shop and have a full data dump from the engineering teams to look at what's happening in the bearings and the wheels and inside the engines. And some of that data has to be processed in real time so they can make decisions on if there's a real issue with the plane while it's in the air or while it's on the ground. And you just can't do that in batch mode. But in other industries that we see out there around finance and health and manufacturing engineering, they're also looking at how they can get, excuse me, this new insight into what's happening in real time as opposed to what's just being stored in their databases on time. There's also this concept of dealing with data as what I call a perishable good or a perishable commodity, and that is that a lot of data loses value over time. And this is more and more the case with mobility apps and social media tools, because what people are saying and what's trending now is what you want to respond to. But when you think about other parts of our lives with logistics and shipping food around, we understand the concept of perishable commodity in that sense. But think about the data that's going through your organizations and the value it has. If somebody's doing some business with you right now and you can interact with them real time, you don't want to wait for an hour for that data to be captured and put into a system like Hadoop and then processed later. You want to deal with it right now, and you want to be able to deal with that client's demand immediately. And there's a term that you'll see pop up a lot now where people talk about having this real-time data stream that can give you personalization, and that personalization tune the system you're using to your individual experience. And so when you hit a tool like Google's search tool, for example, if I do a query and you do the same query, invariably we're not getting exactly the same data. We get essentially what I refer to as the celebrity experience. I'm treated as a one-off. I get my own personal version of what's happening in these systems based on the profiles and data that they've collected on me and are able to do analytics on in real time in the stream. So this idea of data being a perishable commodity is a real thing for us now, and the value of data being diminished over time is something we have to deal with today. It isn't a yesterday thing. I love this picture of a bear grabbing a salmon jumping out of the river, because it really does paint exactly what I see the world being in StreamAnalytix. There's this massive river of data coming at us, a fire hose, if you will, and the bear's sitting in the middle of the creek, and it's got to perform real-time analytics on what's happening around it, such that it can actually engineer its capability to capture that fish in the air. It isn't like it's just dipping in the stream and grabbing one. This thing's jumping in the air, and it's having to be at the right place and the right time to catch that fish, otherwise it doesn't get breakfast or lunch. And organizations want to do the same thing with their data. They want to extract value from what is now massive volumes of data in motion. And they want to perform analytics on that data and high-velocity data. So it isn't just the amount of data that's coming at us, but it's the speed at which it's coming from us. So in security, for example, it's all your routers and switches and servers and firewalls and all the events that are coming from those, and tens of thousands, if not hundreds of thousands of devices in some cases in a traditional data center. And when we think about it in Internet of Things and the industrial Internet, we're talking about millions, if not billions of sensors eventually. And as that data is coming through and we're performing analytics, we're now looking at doing complex event processing at orders of magnitude and speed that we've never even seen before. And we're having to deal with this today, and we're having to build tools and systems around that. And it's a real challenge for organizations, because on one hand, we've got the very big brands out there doing DIY bake it yourself when they've got the capacity to do that and the skill set and the engineering internally. But for the average organization, that isn't the case. They don't have the skill sets internally. They don't have the capacity or the time or even the money to invest in figuring it out themselves. And they're all aiming towards this concept of near real-time decision-making. So the use cases that I've come across, and they are across every broad spectrum of every sector that you can imagine, people are now sitting up and paying attention, saying, how do we apply some analytics to our stream data? We talk about web-scale online services, and they're the traditional sort of social media platforms and online, e-tailing, retailing, mobile apps, for example. They're all trying to give us this real-time celebrity experience. But then we get down into more of the technology stack services, so telecom services, voice and video. The amount of people I see walking around doing FaceTime on phones is just exploding. It boggles my mind that people hold the phone out in front of them and walk along talking to a video stream of a friend as opposed to holding it to their ear anymore. but they know they can do it, and they adopt it, and they like that experience. So the developers of these applications and the platforms that are delivering that service are having to perform real-time analytics on that traffic and on the profiles of the traffic, so they can do simple things like routing that video appropriately so that the quality of the voice in the video that you get is adequate to get a good experience. You can't batch process at time of data. It wouldn't make the real-time video stream a functional service. There's a governance challenge in financial transactions. It isn't okay to get to the end of the day and find out you broke the law. Moving private data around the place. In Australia, we have a very interesting challenge where moving privacy-related data offshore is a no-no. You can't take my PID, my private personal identification data offshore. There's laws in Australia that stop that happening unless you anonymize it. So providers of financial services in particular, and certainly government services and agencies, they have to be doing real-time analytics on their streams of data and interaction with me to make sure that what they're providing to me doesn't leave shore. All the stuff has to stay locally. They've got to do it real time. They can't break the law and ask forgiveness later. Fraud detection, it's a pretty obvious one that we hear a lot about with credit card transactions. But as the types of transactions we're doing in financial services are changing very, very rapidly, the sorts of things that PayPal are doing for us now, detecting fraud in real time where money isn't moving from one bank to another, but it's a financial transaction between systems, eBay's bidding platform. Detecting fraud has to be done in real time in stream analysis. There's a trend moving now to performing extraction and transform and load activities in the streams. So we don't want to capture everything that's going through the stream because we can't really do that. People have learned that data lakes can be broken very quickly if you try and capture everything. So the trick now is perform analytics on those streams and do ETL on it and just capture what you need, potentially metadata. And that drives predictive analytics, where we can actually then tell what's going to happen a little bit further down the path based on what we've just seen in the stream, based on the analytics we performed on it. Energy and utilities providers are experiencing this massive desire from consumers to have demand pricing. I might decide that I want to buy green power one particular time of the day because I'm just home alone and I'm not using a lot of devices. But if I have a dinner party, I might want to have all my devices on, and I don't want to be buying cheap power and waiting for it to be delivered, so I'm willing to pay for more cost to get that power. So this demand pricing, particularly in utilities and energy space, has already happened. We're seeing it everywhere else. I mean, Uber, for example, is a classic example of things you can do every day, and it's all driven by demand pricing. And there are some classic examples of people in Australia getting $10,000 fares because there was a massive demand at New Year's Eve. I'm sure they've dealt with that issue, but that stream analytics being performed in real time while I'm in the car telling you how much I should pay. Internet of Things and sensor streams, we've only just scratched the surface on this, and there's really just a basic conversation happening on this, but we will see an interesting shift in how technology deals with that, because when you're talking not just about thousands or tens of thousands, but hundreds of thousands and potentially billions of devices streaming to you, almost none of the technology stacks we've got now are engineered to cope with that. And there's some really hot topics that we see around the place, like security and cyber risk, and they're very real challenges for us. And there's a really neat tool called North on the web where you can sit and watch on a web page various cyber attacks happening in real time. And when you look at it, you think, oh, that's a nice, cute little web page. But after about 5 minutes in there, you realize the volume of data that system is doing analytics on, and all the different streams of all the different devices around the world that are being fed into them. It starts to boggle the mind of just how they're performing that at the edge of the network and centrally, and providing you this simple little screen that tells you what's pinging something else and attacking it in real time and what type of attack. But it's a really neat little way to just get a good taste of what StreamAnalytix can potentially do for you in real time by just watching this page and getting a sense of just the volume and the challenge of taking their streams, processing analytics queries on them, and representing that in real time. And I think the conversation we're going to have through the rest of the session is going to address all of those types of things with one interesting view from my point of view, and that is that the challenge of DIY and bake it yourself suit some of the classic unicorns who are able to afford to build those types of things. They've got the billions of dollars to build these engineering teams and build their own data centers. But for 99.9% of the organizations out there who want to derive value in their business of StreamAnalytix, they need to get an off-the-shelf service. They need to buy a product out of the box, and they generally need some consulting services and professional service to help them implement it and see that gain that value back into the business and sell it back into the business as a working solution. And with that, I'm going to hand back to you, Rebecca, because I believe that's what we're about to cover in detail now.
Excellent. Thanks so much, Dez. It was a great presentation. And now I will pass the ball to Robin. Take it away.
Okay. Well, because Dez has gone into the nitty-gritty of streams processing, it didn't seem to make sense to me to cover the same ground, so I'm just going to take a completely strategic view, looking almost from a very high level down on what the hell's going on and positioning it, because I think it might help people, especially those people that have not encountered streams processing in any great depth before. I mean, streams processing has been around for a long time. It used to be called CEP. There were real-time systems before that. You know, the original process control systems were actually processing streams of information, of course. Nothing was going as fast as it does nowadays. This diagram, this graphic that you see on the slide here, is just really pointing out, well, it's pointing out a lot of things actually, but it's pointing out above and beyond anything else. The fact that there is a spectrum of latencies that appear in different colors down here, and what's actually happened since the invention of computing or commercial computing that arrived around 1960 is that everything has just got faster and faster. And we used to be able to depend upon the way that this was actually coming out, if you like, in waves, because that's what it looks like. Just be able to depend upon it because it was all driven by Moore's law, and Moore's law would give us a factor of about 10 times speed over a period of about 6 years. And then once we actually got to about 2013, it all broke. And we suddenly started to accelerate at a rate that we've never, was just utterly unprecedented. So, you know, we were getting a factor of about 10 in terms of increase in speed and therefore reduction in latency about every 6 years. Well, in the 6 years since about 2010, we've got a multiple of at least 1,000. So, you know, you've 3 orders of magnitude rather than 1. And that's what's been going on, and that's why the industry in one way or another appears to be moving at a fantastic speed, because it is, you know. So, you know, just going through the meaning of this particular graphic, the response times that actually, by the way, are a logarithmic scale down the vertical axis. Real time is computer speed, faster than human beings. Interactive time, the orange, is when you're interacting with a computer, and therefore you really want 1/10 to about 1 second in terms of latency. And above that's transactional, where you might actually think about what you're doing and responding to the computer. But if that goes out beyond about 15 seconds, it becomes intolerable, and people actually just won't wait for the computer. And above that, everything was done in batch, and a lot of the things that were done in batch are now coming down right into the transactional space or into the interactive space or even into the real-time space. You know, and whereas previously maybe with very small amounts of data we could do some of this, you can now do it with very large amounts of data using hugely scaled out environments. So basically all this is saying is really there's a transactional interactive human response times. An awful lot of what's being done with streams right now is to inform human beings about things. Some of it's going faster than that is informing software, so it's real time. The analytical latencies just dropped like a stone, making instant analytics feasible and incidentally quite affordable. It's not just that the speed has come down and the cost has just collapsed as well. Probably the biggest impact in all of this amongst all of the various applications that you can do like this is predictive analytics, and I'll tell you why I think that in a minute. This is just the hardware story. You know, we've got parallel software starting about 2004, scale-out architectures, multi-core chips, memory increase configurable per CPU, SSDs that now go so much faster than spinning disks that you can pretty much wave spinning disks goodbye. And SSDs are on the Moore's law curve as well, so getting faster and faster. soon to appear, we've got the memory store from HP, and we've got 3D Crosspoint from Intel and Micron, and the promise of those is it will make it all go faster and faster anyway. So, you know, when you're actually thinking of two new memory technologies, both of which will make the whole of the, you know, the fundamental small piece, the individual server circuit board, go way faster, we haven't even seen the end of it, you know. So streams technology, which is the next message really, it's here to stay, you know. There's going to have to be a new architecture, and I mean Dez has kind of mentioned this in several points in his presentations. And for decades we viewed architecture as a combination of data heaps and data pipes. And we tended to process the heaps and we tended to pipe the data between the heaps. We're now moving fundamentally towards what's called the lambda data architecture that combines the processing of data flows with data heaps. You know, so when you're actually processing a stream of events coming in against historical data, it's a data flow with a data heap. I mean, that's what I mean by a lambda architecture. This is in its infancy, and it's only actually part of the picture. If you consider something as complex as the Internet of Everything, which Dez has also mentioned, you actually realize that there's all sorts of data location issues and decisions as to what you should process in the stream. But the thing that I'm really saying here is that when we were processing in batch, we were actually processing streams. It's just we couldn't do it one at a time. So we just wait till there's a big heap of stuff and then we process it all at once. And we're moving to a situation where we actually can process stuff in the stream. And if we can process stuff in the stream, then the data heaps that we hold are going to be the static data which we need to reference in order to process the data in the stream. This takes us towards this particular thing, and I've mentioned this before in some presentations, but the biological analogy. And the way that I'd like you to think about this at the moment, we are human beings. We have three distinct networks for real-time predictive processing. They're called the somatic, the autonomic, and the enteric. The enteric's your stomach. The autonomic is the autonomic nervous system looks after fight and flight. So it actually looks after fast reactions to the environment. And the somatic, which just looks after the moving of the body. And those are real-time systems. And the interesting thing about them, or I think they're kind of interesting, is a lot of them are more predictive than you would ever imagine. It's if you're actually looking at a screen right now, then about 18 inches from your face, all that you can see clearly, all that your body is capable of seeing clearly, is in actual fact about an 8 by 10 square rectangle. And everything outside of that is actually blurred as far as your body's concerned, but your mind is actually filling in the gaps and making it not blurred. You don't see it blurred at all, you see it clear. And your mind is actually doing predictive massaging of the data stream in order for you to see that clarity. And that's kind of a curious thing, but if you actually look at the way the nervous system operates and the way that we manage to get around and behave reasonably, or at least some of us manage to behave reasonably sanely and not bump into things all the time, it's all done by a series of neural analytics that's going on inside you. And what's going to happen is organizations are going to have the same kind of service and they're going to build the same kind of thing. And it's going to be the processing of streams, including the internal streams of the organization, the things that are happening within it, the things that are happening outside it, the instant responses that actually have to be made, and of course feeding the human beings that are going to make decisions to make all of this stuff happen. And that's where we're going as far as I can see. And one of the things that is a consequence of that is that the level of the streaming applications is going to, there's going to be an awful lot more than we see now. Right now we're picking the low-hanging fruit and doing the things that are obvious. So anyway, the conclusion here. Streaming analytics was once a niche, but it's becoming mainstream, and it will soon be adopted generally. And with that, I shall pass it back to Rebecca.
Thanks so much, Robin. Great presentation as usual. And Anand, you're up next. The floor is yours.
Fantastic. Thank you. So my name is Anand Venugopal, and I'm the head of product for StreamAnalytix. It's a product offered by Impetus Technologies out of Los Gatos, California. Impetus has had actually a great history in being a big data solutions provider for large enterprises. So we've actually done a number of streaming analytics implementations as a services company, and we learned a lot of lessons. And we also took a shift to becoming a product company and solutions-driven company in the last couple of years, and StreamAnalytix is heading the charge in transforming Impetus into a largely product-driven company. There's some critical, very, very key assets that Impetus has created thanks to our exposure to enterprises, and StreamAnalytix is one of them. So we're 20 years in the business, and there's a great mix of products and services, and that makes it a huge advantage. And StreamAnalytix was born out of all the lessons learned from our first 5 or 6 implementations of streaming. So I will touch upon a few things, but the analysts Dez and Robin have done a fantastic job at covering the space overall, so I'm going to skip a lot of the content that overlaps or probably go fast. We see besides through streaming cases, we're seeing a lot of just batch acceleration where, there's literally very, very important batch processes in enterprises. And as you can see, this whole cycle of sensing an event and analyzing it and acting on it could take actually weeks in large enterprises. And they're all trying to shrink it down to minutes and sometimes seconds and milliseconds. So anything faster than all of these batch processes would are candidates for business acceleration. And then as Des very well put it, the value of data dramatically diminishes with its age. So the more value there is in the initial portion than the seconds that it was just happened. Ideally, if you could predict what was going to happen, that is the highest value. But that depends on the accuracy, though. And the next highest values, when it's right there, when it's happening, you can analyze it and respond. And of course, the value dramatically reduces after that, and that's the domain of descriptive BI that we're in. It's interesting. You might expect some dramatically scientific answer to why streaming analytics, but in many, many cases, what we're seeing is it's because it's now possible, and because everybody knows batch is old and batch is boring and batch is not cool. There's enough education that everybody has had now on the fact that there's streaming possible, and everybody has Hadoop now, and all the Hadoop distributions have a streaming technology embedded in it, whether it's Storm or Spark streaming, and of course the message queues like Kafka, etc. So enterprises we see are jumping into it and starting experimenting with use cases, and we are seeing 2 broad categories of use cases. One is something to do with customer analytics and customer experience, and the second is operational intelligence. And I'll get into some of the details on that a little later. The whole customer service and customer experience angle, and we at Impetus and StreamAnalytix have done this over in many different ways, is all about really truly capturing the multi-channel engagement of the consumer in real time and give them very, very context-sensitive experiences, which are not common today. If you were browsing on the web on a Bank of America website and you were researching some products and you just called the call center, would they say, "Hey Joe, I know you were researching some banking products. Would you like me to fill you in?" You don't expect that today, but that's the kind of experience that's possible, truly possible with streaming analytics. And in many cases, it makes a huge difference, especially if, let's say, with the customers actually researching ways to get out of their contract with you by looking at, early termination clauses, early termination, terms and conditions on your website, and then they call in, and you're able to not directly confront them about it, but just indirectly make an offer to them about, some kind some kind of a promotion because the system knows that this person is looking at early termination, and you make that offer at that point, you could very well protect that churning customer and protect that asset. So that would be one example, plus a lot of customer service-oriented examples we are implementing today brings down the cost in the call center as well as provides dramatic, delightful customer experiences. So, you know, this is, Dez did a great job in summarizing some of the use cases. You can stare at this chart for a couple of minutes. I've classified it as verticals, horizontals, and kind of combo areas, IoT, mobile app, and call center. They're all verticals and horizontals, and depends on how you look at it. So bottom line, we see a good deal of horizontal use cases that are fairly common across industry verticals. And there's vertical-specific use cases, including financial services, healthcare, telecom, manufacturing, etc. And so if you're really asking yourself the question or telling yourself that, oh, I don't know what use cases there are, I'm not sure if there is really any business value in streaming analytics for my company or for our enterprise, think hard, think twice, talk to more people, because there are use cases that in your company are relevant today. And I'll get into the business value and how exactly the business value is derived, right? So at the bottom of the pyramid here, you have predictive maintenance, security, churn protection, etc. Those kind of use cases constitute protection of revenues and assets, right? So if Target protected that security breach, which happened over hours and weeks, they could have, you know, the CIO could have saved his job, they could have saved tens or hundreds of millions of dollars, etc. So real-time streaming analytics really helps in protecting those assets and protecting losses. Okay, that's direct business value added right there. The next category is becoming more profitable, lowering your costs, and deriving more revenues from current operations, right? That's efficiency of the current enterprise. And those are all the category of use cases that we call real-time operational intelligence, where you're getting deep insights into how the network is behaving, how your customer operations are behaving, how your business process is behaving, and you're able to tweak all of that in real time because you get feedback, you get alerts, you get deviances, variances in real time, and you can quickly act and set right the process that's going out of bounds. And you could potentially also, you know, save a lot of money in expensive capital upgrades and things which you think are necessary, which may not be necessary if you optimize the network. So recently we had a case, or we heard of a case where a major telco, you know, deferred a $40 million upgrade in their network infrastructure because they found that they had enough capacity to manage their current traffic, but just by optimizing and better doing intelligent routing of traffic and things like that. And those are all possible only with some kind of a real-time analytics mechanism and an action mechanism that acts on those insights in real time, right? So the next level of value add is upsell, cross-sell, where there are opportunities to make more revenues and profits from current offerings. So this is a classic example that many of us know about and have experienced, where, you know, think about in your life where you are willing to actually buy a product today that is not being offered to you, right? In many cases, that actually happens. You have things in your mind that you'd like to buy, that you know that you want to buy. You have on a to-do list or something that your wife told you, or if you're the wife, then that you're really planning to buy. And you're either shopping on a website or you're interacting with in a retail store. The storefront just does not have the context, doesn't have the intelligence to compute what you might need. And hence they don't get that business. So if streaming analytics could be deployed to really make accurate predictions, and which are really possible on what would most suit this particular context, this customer at this time, at this location, there's a lot of upsell, cross-sell, and that again comes from streaming analytics, being able to make a propensity decision of what this customer is likely to buy or respond to in that moment of truth when there's an opportunity. And just I love that picture that Dez showed with the bear and just about to eat that fish. that's pretty much it, right? We also think there is a big category out there of dramatic transformational changes in an enterprise of offering completely new products and services simply based on observation of customer behavior or based on the observation of the behavior of another enterprise. So if, let's say, if a telco or a cable company is really observing the usage patterns of customers in what segment of the market is viewing what program at what time, et cetera, they actually end up creating products and services that are being almost begged for in some ways, right? So the whole concept of multi-screen behavior right now, where we are now almost taking it for granted that we can see TV on our cable content on our mobile apps. Some of those examples are coming from those new products and services that are being offered to us. So I'll get into, what are the architectural considerations of streaming analytics. It's ultimately what we're trying to do is blending. This is the Lambda architecture, right, where you're blending the historical data and the real-time insights and seeing it at the same time. That's what StreamAnalytix also enables. And so we all have the batch architecture and enterprise picture today, leading into some kind of a BI stack and visualization stack. And the Lambda architecture adds the speed layer underneath, and the Lambda architecture is all about merging those two insights and seeing that in a combination, in a combined way, in a rich way that combines both insights. And there's another paradigm called the Kappa architecture that has been proposed, where the conjecture is that the speed layer is the only input mechanism that's going to persist in the longer term. So everything is going to come through the speed layer. There's not even going to be an offline ETL mechanism. All the ETL will happen, data cleansing, quality, ETL, all of that will happen on the wire. Because keep in mind that all data was born real time. At some point it was real time. We've gotten so used to putting it on disks and lakes and rivers and oceans now, right? And then doing static data analysis that we forgot that the data was born at some point in real time. So all data is actually born as a real-time event that happened in a point of time, and most of the data today on the lake just got put on a database for later analysis, and we have now the advantage in the Lambda and Kappa architecture of actually seeing it, analyzing it, pre-processing it, reacting to it as it arrives. So that's what is enabled by these technologies. And when you look at it as the overall picture, it looks like something like this, where there's Hadoop inside, there's MPPs and data warehouses that you already have. We put this up because it's important to not just talk about new technologies in an island. They have to integrate. They have to make sense in the current enterprise context. And as solution providers that are serving enterprises, we are very sensitive to this. We help enterprises kind of integrate the whole thing. So there's data sources on the left side feeding into both the Hadoop and data warehouse layers, as well as to the real-time layer on top. And both of those and each of those entities is talking to each other, as you can see. And the data consumption layer is on the right side. And of course, there's a constant effort to move the maturity of compliance, governance, security, lifecycle management, et cetera, that's available today on RDBMS into all of these new technologies. So one of the things that StreamAnalytix is trying to do, if you look at the landscape today, there's a lot of stuff going on in the streaming technology landscape. And from an enterprise customer point of view, there's so much to understand, there's so much to keep up with, right? There's data gathering mechanisms on the left side, NiFi, Logstash, Flume, Scoop, and obviously I've put up this disclaimer saying that it's not exhaustive. Coming into the message queues, and then coming into the open source streaming engines, Storm, Spark Streaming, Samza, Flink, Apex, Heron. Heron is probably not open source yet, I'm not sure if it is, from Twitter. And those streaming engines then lead into or support a set of analytical application components such as complex event processing, machine learning, predictive analytics, an alerting module, streaming ETL, enrichment, statistical operations, filters, etc. All those are all what we call now as operators, right? And a set of those operators, when stringed together with potentially also some custom logic included if necessary, becomes a streaming application that runs on a streaming engine. And as part of that chain of components, you also need to store and index the data into your favorite database, your favorite index. You might also have a distributed cache. And again, that leads into the data visualization layer on the right side, on the top right, to there are commercial products, there are open source products, but ultimately you need some sort of a product to visualize that data in real time. And also you need to sometimes trigger other applications. So when we've all seen that the value is derived only by the action that you take on the insight, that action is going to be a trigger from an analytical stack into another application stack that maybe changes, that does something on the IVR side or triggers a call center outbound call or something like that, right? So you need to have those systems integrated and some mechanism for your streaming cluster to trigger off other applications or send data downstream. So that's the overall stack from going from left to right, and then of course you have the service layers in the middle, the monitoring, security, general service layer, etc. And coming to what products that are out there in the enterprise space that customers are seeing, right? There's Hadoop distributions, which all have streaming, like I said, and there's commercial or single vendor solutions that are obviously in our competitors, and there's many more as well in the landscape that we may not have mentioned here. What you're seeing there is broadly the enterprise user seeing a complex and rapidly evolving technology landscape for stream processing, as you can see, right? We got to simplify the choice and the user experience. So what we think enterprises really need is a functional abstraction of all of that in one-stop shop, easy-to-use interface that brings together all of those technologies that makes it really simple to use and does not expose all of the moving parts and the integration issues and the performance issues and the life cycle maintenance issues to the enterprise. So the functional abstraction is one, and the second part is the streaming engine abstraction. So the streaming engines in the open source domain are coming up once every 3, 4, 6 months now, right? It was Storm for a long time. Samza came up, and now Spark streaming. Flink is, raising its head, beginning to get popularity, get attention. Even the Spark streaming roadmap, they're making way for potentially using a different engine for pure event processing because they also realized that, Spark was designed for batch, and they're making way in their architectural vision and the roadmap for potentially having a different engine for stream processing, in addition to the current micro batch paradigm on Spark streaming. So it is a reality that you have to contend with, that there's going to be a lot of evolution, and you really need to protect yourself from that technology flux, because by default you're going to have to pick one and then live with it, which is not optimal, right? That's the reason why we feel, and you're looking at it another way, you're fighting between, okay, I got to buy a proprietary platform where there's vendor lock-in, there's no leverage of open source, could be very high cost, limited flexibility, versus all of this open source stack where you have to do it yourself. And again, like I said, it's a lot of costs and delay in getting to market. So what we're saying is StreamAnalytix is one example of a great platform that pulls together the enterprise class, reliable, single vendor supported professional services, all of that you really need as an enterprise, and the power of flexibility of the open source ecosystem, right, where a single component, a single platform brings together ingest, CP, analytics, visualization, all of that. And it also does a very, very unique thing, which is brings together many different technology engines underneath one single user experience. So we really think the future is about being able to use multiple streaming engines, because different use cases really demand different streaming architectures, right? Like Robin said, there's a whole spectrum of latencies. So if you're really talking about millisecond latency level, tens or even hundreds of milliseconds, you really need Storm at this time until there's another equally mature product. For less lenient for more lenient time frames and latencies of maybe in a couple of seconds, 3, 4, 5 seconds, that range, then you can use Spark Streaming, and potentially there are other engines that could do both. But bottom line, in a large enterprise, there's going to be use cases of all kinds. You really want the access and the generality to have multiple engines with one user experience, and that's what we've tried to build in StreamAnalytix. So just a quick view on the architecture. I know this is kind of a busy slide. We got to rework this a little bit, but essentially there's multiple data sources coming in on the left side: Kafka, RabbitMQ, Kinesis, ActiveMQ, all of those data sources and message queues coming in to the stream processing platform, where you get to assemble an app, right? You get to drag and drop different operators like the enrichers, ETLs, all the stuff that we talked about. And underneath, there are multiple engines. So right now, we have Storm and Spark Streaming. It's the industry's only and first enterprise-class streaming engine that has a streaming platform that has multiple engine support. So that's a very unique flexibility we are offering, besides all of the other flexibility of having real-time dashboards, the CEP engine embedded. You have the seamless integration with Hadoop and NoSQL indexes, Apache Solr, and Elasticsearch. You can land the data into your favorite database, no matter what it is, and build applications really quickly and get to market really quickly and stay future-proof. So that's our whole mantra in StreamAnalytix. So with that, I think I'll conclude my remarks. So feel free to come to us for more questions. I'd like to keep the floor open for Q&A and panel discussion. Rebecca, over to you.
Great. Okay. Thanks so much. And Dez, Robin, you have some questions before we turn it over to the audience Q&A?
Well, I've got a question. I'll put my headphones back on so you can hear me. One of the interesting things, and really I'd like, Anand, if you could comment on this, a lot of what I've been seeing in the open source space looks, what I would say, immature to me. In a sense that, yes, you can do various things, but it looks like we're looking at software that's in its first or second release in reality. And I was just wondering, your experience as an organization, how much do you see the immaturity of the Hadoop environment as problematic? Or is it something that, it doesn't create too many problems?
It is a reality, Robin. You're absolutely right. The immaturity is not necessarily in the area of just functional stability and things. There may be some cases of that too, but the immaturity is more in readiness of usage, right? The open source products as they come out, and even as they're offered by the Hadoop distribution, they're all a lot of different capable products and components just slapped together. They don't work together seamlessly, and they're not designed for a smooth, seamless user experience that will get like a Bank of America or a Verizon or an AT&T out to deploy a streaming analytics application within weeks. They're not designed for that, for sure. That's the reason why we come in, we bring it together and make it really easy to understand, to deploy, etc. And the functional maturity of it, I think, to a large extent is there. Many large enterprises use, for example, Storm today. Many large enterprises are playing with Spark Streaming today. They have that each of these engines have their limitations and what they can't do. That's why it's important to know what you can and what you can't do with each engine. And there's no point breaking your head against the wall and saying, look, I chose Spark Streaming and it doesn't work for me in this particular use case. Yeah, it's not going to work. There are going to be use cases where Spark Streaming is not going to be the best option, and there are going to be use cases where Spark Streaming may not work at all for you. That's why you really need multiple options.
Yeah, and I think you need to help. Well, you need to have expertise on board for most of this. I wouldn't even start unless I had a sensible collection of skilled individuals. I'm interested in how the engagements that you get involved in, how they happen. Is it because a particular company is after a specific application, or are you seeing kind of what I would call strategic adoption, where they want a whole platform to do a lot of things?
We are seeing examples of both, Robin. There are large, the largest brands, some of the top 10 brands that everybody knows are going about it in a very strategic way. They know that they are going to have a variety of use cases, so they're evaluating platforms that will suit that need, which is a variety of different use cases in a multi-tenant manner to be deployed in an enterprise. And there are single use case stories that are starting as well. There's a particular business activity monitoring type use case in a mortgage company that we're working on, which you would not imagine as your first use case, but that is the business solution or use case they came up with, and then we connected the dots to streaming and said, you know what, this is a great case for streaming analytics, and this is how we can implement it, and that's how it's starting. And then in that process, they get educated and say, oh, wow, if we can do this, and if this is a generic platform, then we can separate the application layer and the platform and build a lot of different applications on this platform.
Right. Dez, have you got, I don't want to hog this. Dez, have you got any questions? Dez?
Dez is probably on mute.
Apologies, mute. I just had a good conversation with myself. Just following on following on your original observation there, Robin, you're absolutely correct. I think the challenge now is that enterprises have an ecosystem and a cultural and behavioral environment where free and open source software is something that's known to them, and invariably they'll use tools like Firefox as a browser, and it's had a decent lifetime to become stable and secure. But some of the very big platforms that use are enterprise grade, proprietary platforms. And so the adoption of what are considered open source platforms is not always something that's easy for them to, culturally or emotionally get across. And I've seen this across just the adoption of small programs of work or projects to just, play with big data and analytics as a fundamental concept. So I think that one of the key challenges I'm sure you're seeing now across the Impetus organization is this desire to get the outcome, but at the same time having sort of one foot stuck in the old camp of, we just buy this from insert name a big brand of, the Oracles and IBMs and Microsofts. These new unknown brands are coming through with the Hadoop platforms, and even more boutique and exciting brands are coming through with bleeding edge technology like Stream. What are the sorts of conversations you've had that kind of get through or cut through that, I think, because I know that we're going to have, and we've got a massive attendance this morning, and one of the things I'm sure is on everyone's mind is how do I cut through that whole challenging layer from board down to management level of, oh, well, it's open source and it's too bleeding edge. How do the conversations you're having with clients go, and how do you cut through to that point where you can kind of allay those types of fears in a traditional enterprise environment to consider adopting the likes of StreamAnalytix?
We're actually finding it fairly easy to sell our value proposition because customers are naturally moving towards open source as a preferred option. They are not easily just giving up and saying, okay, I'm going to go open source, right? They actually go through a very committed evaluation of a major product. Let's say it's an IBM or a TIBCO product, because they have these vendor relationships, right? They can't just ignore them. So they will pit us or the open source engine against that product. They will go through, 6 to 8, 12 weeks of evaluation. They will convince themselves that there is a degree of performance and stability here that I want, and then they make up their mind saying, wow, you know what, I can actually do this. And today, for example, we have a major tier 1 telco has StreamAnalytix running in production on top of a Hortonworks stack, and they're evaluating us against another large, very, very large, well-known vendor, and they were convinced only after we proved all the performance, the stability, and all of those things. So they don't take it for granted. They put us on the open source component through the evaluations, and they realize that worst case maybe there is those 2 use cases that I maybe can't do, but most of my business acceleration use cases today are eminently possible with the open source stack, and we enable usage of it. So that's the big sweet spot, right? They want to do open source. They're really looking to get out of the vendor lock-in situation that they've been used to for many, many years, and then here we come and say, you know what, we'll make open source much, much easier and friendly to use for you.
I think the other challenge that enterprises find is that when they bring in the traditional incumbents, they're often a generation behind some of the bleeding edge, exciting stuff that we're talking about here, and I don't mean that as a negative slight. It's just the reality is they've got a generational journey to go through to release what they consider stable platforms, or to go through old school development and UAT and integration cycles and testing and documentation and marketing and sales. And whereas the type of thing you're doing, and I think that the thing that I was very interested to read about when I was looking at some of your latest releases last night and doing some just current research was you've got this mix now where you've got the competency from an upfront consultancy point of view and the implementation, but you've also got a stack that you can roll in. And I think this is where the incumbents are going to struggle for some time, and we've seen many of them like IBM and Microsoft reinvent themselves regularly to get to these markets, but they're often in what I call catch-up mode, whereas I think from what you're telling us, you're out there today having those conversations and you're out there implementing. Can you give us a couple of examples of some of the broader verticals that you've seen adoption in? For example, I mean, there's really niche environments like rocket science and putting satellites in space and collecting data from Mars. There's only a handful of people doing that on the planet. But in very big verticals like health, for example, in aeronautics, and in shipping and logistics and manufacturing and engineering, what are some of a couple of examples of the larger and more broad industry sectors you've been in so far that you've seen really good adoption in? So
telco is a big example, right? I'm going to just click on some slides here. Are you able to see this?
Yes.
Slide here, case study number 4. So, this is a case of a large telco, ingesting set-top box data and doing multiple things with it. They're looking at, what customers are really doing in real time. They're looking at where errors are happening in real time in set-top boxes. They're trying to inform the call center on where the errors are. And if this customer calls in right now, they correlate the information from this customer's set-top box, maintenance ticket information, and quickly correlate whether this particular customer's set-top box has a problem or not, even before the customer speaks a word. So that's every cable company, every major telco is trying to do this, right? Ingest set-top box data, do real-time analytics, do campaign analytics so that they can place their ads, etc. That's a huge use case pattern that we see. There's this, as I said, this mortgage company, which is again a generic pattern where large systems are involved in processing data from the data flows through system A to system B to system C, and these are regulated businesses that everything needs to be consistent, right? And often systems go out of sync with each other. One system is saying, well, I processed 100 loans with a total value of $10 million. The other system is saying, no, I processed 110 loans of some other different number. And they have to resolve that really quickly because they're in fact processing the same data and making different interpretations. So whether it is a credit card loan processing business process or whether it's a mortgage business process or something else, we're helping them to do correlation and reconciliation in real time, to ensure that those business processes stay in sync. But that's another interesting use case. And there's a major U.S. government contractor who's looking at DNS traffic to do anomaly detection. There's an offline training model that they build, and they're doing the scoring based on that model on real-time traffic. So some of those interesting use cases. There's a major airline looking at security queues and they're trying to give you the information that, hey, at your gate for your plane, for your flight, the TSA queue today is about 45 minutes versus 2 hours versus something else. You get that update up front, and they're still working on it. Interesting IoT use case, but great case of streaming analytics adding to the customer experience.
And this is Rebecca. While you're on the subject of use cases, there's a great question from an audience member who's wondering, are these case studies, are these initiatives being driven from the information systems analytics side of the house, or are they more being driven from the business who has specific questions or needs in mind?
I think we see about 60% or so, 60-65% largely very proactive, enthusiastic technology initiatives who happen to know, who happen to be fairly savvy and understand certain business requirements, and they probably have one sponsor that they've identified. But this is technology teams getting ready for the onslaught of business use cases coming through, and then once they build a capability, they know that they can do this, and then they go to business and aggressively sell this. And in 30 to 40% of cases, we see business has a particular use case already, which is begging for streaming analytics capability.
That makes sense. And I've got another slightly more technical question from an audience member. He's wondering if these systems support both structured and unstructured data streams, like sentiment of Twitter streams or Facebook posts in real time, or does it need to be initially filtered? The products and technologies that we're talking about very eminently support both structured and unstructured data. They can be configured. It's all data has some kind of structure, right? Whether it's a text or an XML or anything at all, there's at least some structure in terms of there's a timestamp field, and there's maybe another blob which needs to be parsed. So you can inject parsers into the stream to parse out the data if it's unstructured, and if it's structured, then we just tell the system, okay, this is comma separated values, and the first one is a string, second is a date. So we can inject that parsing intelligence into the upstream layers and process easily both structured and unstructured data. Okay, good. And then I've got another question from the audience. I know we've run a little bit past the top of the hour. This attendee wants to know, it seems like real-time streaming applications may be developing both a need and an opportunity for integrating back into transaction systems. Fraud prevention they bring up. For example, in that case, do the transaction systems need to be tweaked to kind of fit with that? So
it's a merge, right? It's a merge of transaction systems may sometimes become the source of data where we're analyzing transactions in real time. And in many cases where, let's say, there's an application flow, and here I'm trying to show static data lookups, right? And in our case, where some sort of streaming data is coming in, and you're looking up a static database like an HBase or an RDBMS to enrich the streaming data and the static data together to make a decision or an analytical insight. So we see both. And of course, there's another big industry trend that we are also seeing, the convergence of OLAP and OLTP, and that's why you have databases like Hadoop and in-memory databases supporting both transactions and analytical processing at the same time. And a stream processing layer would be entirely in memory and would be looking at or interfacing with some of these transactional databases.
Okay. Yeah, mixed workloads has been one of the last hurdles to jump, I think. Dez, Robin, do you two have any more questions?
I'm going to jump in with just one last question and wrap up on that, if you don't mind. The first challenge that the organizations that I've been dealing with for the last decade or so, leading into this sort of new exciting challenge of StreamAnalytix, the first thing they tend to put back on the table when we start a conversation around this whole challenge is where do we get the skill set, or how do we retrain the skill set, and how do we get that capability internally? And having Impetus come in and handhold us through the journey and then implement something is a great first step, and it makes a lot of sense doing that. But for a medium to large organization, what are the kinds of things you're seeing them do at the moment to prepare for this, to build that capability internally, get anything from just a basic vocabulary around it, and what sort of messaging they do with the organization around the transition to this sort of framework, and retooling their existing technical staff, their IT, from the CIO down, so they can run this themselves once you've built it and implemented it. Just very briefly, what sort of challenges and how are they solving them, the customers you're dealing with, the types of challenges they've found and how they go through solving that, retraining and regaining experience and knowledge to get ready for this and to be able to run it operationally?
So often the small set of people that are trying to go out and buy a streaming analytics platform is already reasonably smart, and in that they're Hadoop aware, they've already gotten their Hadoop MapReduce skills, and because they're working closely with the Hadoop distribution vendor, they're either familiar, everybody's heard of Kafka, for example, and doing something with it, and either Storm or Spark streaming is in the open source domain. It's definitely people are familiar with it or building skills around it. But it starts with a small set of people that are skilled enough and are smart enough. They're attending conferences, they're learning, and then they ask intelligent questions to vendors. And in some cases, they learn with the vendors, right? As the vendors coming and presenting at the first meeting, they may not know stuff, but they go read up and then they start playing with it. So that small group of people is the nucleus, and then it starts growing, and everybody now realizes that when the first business use case gets operationalized, there begins a wave, right? And we saw in the Spark Summit last week where a large enterprise like Capital One was out there in full strength. They're adopting Spark. They were speaking about it. They're educating a lot of their people in Spark because they're contributing to it also in many cases as a user. So and we see the same with many large enterprises. It starts with a small set of very smart people, and then it begins a wave of overall education, and people know that once a senior VP or once a senior director is aligned and they want to bet on this thing, the word gets around and they all start, picking up these skills.
And I'm sure you've got a fantastic team of folks who can build those champions too.
Yes. And we do a lot of education as we work with the initial champions, and we hold training courses, and many of our large customers we have gone back and had waves and waves of training to bring a lot of the users into the mainstream usage phase, especially in the Hadoop MapReduce side. We found that in a large credit card company who's a customer of ours, we've delivered at least maybe 5 to 8 different training programs. And we also have, free community editions of all these products, including ours, sandboxes that people can download, get used to, and, educate themselves that way also.
That's all I have this morning for you, and thank you very much. I found it incredibly interesting to see the types of models and use cases you've been able to put forward today. Thank you.
Great. Thank you very much, folks.
Okay, and thanks everyone for joining us on this Hot Technologies webcast. It's been fascinating to hear from Dez Blanchfield, Dr. Robin Bloor, and from Impetus Technologies, Anand Venugopal. So thank you presenters, thank you speakers, and thank you audience. We have another Hot Technologies next month, so look for that. You can always find our content archived at InsideAnalysis.com. We also put lots of content up on SlideShare and some interesting bits on YouTube as well. So that's all, folks. Thanks again, and have a good day. Bye-bye.
Thank you.